In this video, we are going to discuss about summing amplifiers. This circuit will combine a several signal into a single common signal. It combines several signals into a single common signal. Its applications are used in broadcasts, and it is used in recording industries. That is in stereo left and right. So the ideal summing amplifiers would present each input signal with an isolated load which is not affected by other channels. So this is the most common summing amplifier is nothing but it is an extension of the inverting voltage amplifier. Okay, so it is an extension of a inverting voltage amplifier. Okay, because the input of the op-amp is at virtual ground, right? So if you see the diagram, you can identify. Okay, basically for inverting amplifier, this is your inverting amplifier, right? So at the input voltage is given at the inverting terminal of an op-amp, right? So this is called as an inverting amplifier, and RF is nothing but the feedback resistance, and R is input resistance, and for the positive of the op-amp, that is a non-inverting terminal, it is grounded. Okay, so this is nothing but inverting amplifier, but what I am going to do is here I am going to since it is an extension of non-inverting amplifiers, I am going to add three or I can add more. Several resistance. I can name it as V1, V2 and Vn. Okay. So this is nothing but your summing amplifiers. Okay. So what will be for inverting amplifier, AV is equal to minus RF divided by R1, right? So what is AV? AV is nothing but V0 by V1, Vi. That is nothing but minus RF by R. Okay. But here what is gain means AVN. I can term it as AVN minus RF divided by Rn. Okay. So what will be my output? Here I can write V0 is equal to minus RF divided by R into Vi, right? So here I can write it as Vout is equal to, for V1, AV1, it is nothing but minus RF divided by R1 into V1, right? For n is equal to 2, it is Rf divided by R1 R2 V2, right? Next, it will goes on and it will end at Rf divided by Rn into Vn, right? So this term I can write it as AV1, right? AV1 into V1 plus AV2 into V2 plus AVN because AV is equal to minus Rf divided by R. AV1 is nothing but minus Rf divided by R, right? Yeah. So this I can write it as V out is equal to summation of n is equal to 1 to n AV n into V, sorry, smaller, AV n into Vn. Okay. So this summing amplifier may have equal gain for each input channel. So it is called as, therefore it is called as equal weighted configuration. So let us discuss one problem on summing amplifier. So I have connected 3 resistors and their values are 4K, 2K and 1K, and DC voltage. This is a DC voltage, 1 volt, minus 2 volt and plus 5 volt is connected, okay, plus 0.5 volt, okay, is connected to an inverting amplifiers. So they are asked to find the value of V0, okay. So we know that V0 is equal to summation n is equal to 1 to n AV1 AVN into Vn, right? So here I have 1 to 3, capital N value is 3. So I can write it as AV1 into V1 plus AV2 into V2 plus AV3 into V3. Am I right? So what is the value of V1? V1 is equal to 1 volt and V2 is equal to minus 2 volt and V3 is equal to 0.5 volt. Okay. So I need to find the value of AV, right? AV1. So what is AV1? AV1 is equal to minus RF divided by R1. That is nothing but minus RF is, they have given it as 10K. Okay. So minus 10K divided by R1 value is 4K. So this is nothing but 2.5, right? So from that I can, okay, what is AV2? AV2 is equal to minus RF divided by R2. That is nothing but minus 10K divided by 2K. So it is nothing but minus 5. What is AV3? AV3 is equal to minus RF divided by R3. That is nothing but minus 10K divided by 1K. So that is nothing but minus 10. Okay. So you need to substitute the values in V naught. What is V naught? V naught is nothing but AV1 into V1. So that is nothing but minus 2.5. AV2 is minus 5 volt into minus 2 plus minus 10 into 0.5. Okay. So what is it value? Minus 2.5 plus 10 minus 5. Okay. So it is nothing but 2.5. Am I right? So if the suppose if the input signal is AC, means this is not as simple as it is, because for the AC signal it is you have different frequency, right? So the calculation you have to proceed it by finding the RMS values. Okay. So the calculation is a bit different. Okay. So by adjusting the value of input resistance, you can see the gain get varied, right? So you can see this the summing amplifiers is also used in the as a level shifter. Okay. So here for the level shifter, one input should be AC signal and another one is DC signal, right? So the proper selection of the DC values let you place the AC signal at a desired DC offset. Thank you.